Next area we go to is water measurement. Now, these flows are being measured. If we're diverting water out of the stream, it's being monitored as how much we're diverting. Now, surface water, if we're diverting it into a canal, we can measure it with a weir. We just spill it over a weir, and we know if the water's spilling so high over a weir so wide, we just multiply the area times the velocity and we find the flow. So very simple, and weirs have calibrations on them so that you can calculate the flow being spilled over a weir. That's pretty easy. And for example, we have some major ditches in this valley, and that's how they determine their water, and they have certain water rights they're allowed. So you go down here to the Burlingame ditch, and it's a big ditch. It's probably, I don't know, 20 feet wide and 10 feet deep, and they can flow the whole darn river down the thing almost. And they have a weir that they drop the water through to spill into that ditch. And they're given certain water, and the water master is monitoring the total stream flow coming down the Walla Walla River and is letting them know on a day-to-day basis what their allotment is for that day. And as the summer gets further into June, their allotment gets less and less and less and less, and pretty soon, sometime in July or late June, they get shut off. Clear up until October, and then they start getting water again sometime generally in September or October when the stream starts building volume again. So we can measure with weir on surface water. There's also a partial flume that can be used on a surface ditch, a narrow, small ditch. You actually run it through a chute, a narrow chute, kind of like a surface venturi. You neck it down and create a backwater so it spills over this little speed bump you've put in the ditch effectively. And you can measure the height differential from one side to the other of this little thing called a partial flume and figure out the water flow in that ditch. And that works up to ditches, you can get them pretty wide, but generally they're put in small ditches, 1, 2, 3 feet wide. And they can be used very nicely. It's a little more expensive than putting in a weir, but it can be done where the flow is, there's not enough elevation drop to have a pure weir to spill over. Sometimes the ground's too flat to put a weir in. So you can use a partial flume. It's also something you can go out and just insert anywhere in any ditch. You can set it up in a few minutes and run the ditch through it and find out what the flow is. Out of pumps, then we use flow meters. And it's very popular on the downstream side to monitor the flow coming out the downstream side.
How do you spell weir?
Weir? W-E-I-R. It's kind of backwards. Bring that on up. Come around this way. Now here's a flow meter. One style is a propeller style. Thank you. And this would latch right on to an 8-inch pipe. Saddle clamp, you'd have to drill a hole in the top of the pipe, drop this into the hole, clamp it into place, and it's going to record, and this thing just spins. So as the water comes across it, it spins a propeller, and the speed of the propeller will tell us the velocity of the water in the pipe, and we know the cross-sectional area of the pipe. It's 8-inch diameter, so we can find the cross-sectional area times the velocity equals the flow. Well, we don't even have to do the math because it has a calibration on it, and all it has to do is be monitored. Okay, and right here it converts it to gallons per minute for us. And so we can relate, or gallons, I'm sorry, total, yeah, it reads gallons per minute on the dial, so we can tell what the flow rate is at any instant. And then it also records total gallons used. So it's recording, and it's times 100, so it's big, big numbers. You know, normally we're looking at millions of gallons per day in big pipes like this. But it's a like an odometer on the car. It's recording a cumulative amount of water passed through the pipe. So not only it's like a speedometer, it's also like an odometer. Gives us velocity, which then converts directly to gallons per minute of flow at that instant, plus it's also logging the total gallons passed through it. And so if we want to know how much we used in a day or a week or a month or a season, we have a log of it. And so does the state. And so we know how much water is being used in that particular system. And it's a great way to monitor water use in crops as well. Because what we want to do is, part of what we want to know in growing a crop is how much did we have to spend on water. So we know how many gallons of water we used a year on that particular crop.
Do you have like a reset button on there?
I don't believe so. I shouldn't say that. There's got to be a way to get into it. There is right here. In fact, they made it tamper-proof because you can take the top off and reset the dials. And so they have a tag, a tamper-proof tag, so that you can't do that. It's kind of like your meter at your house for the power company. You know, they got a little tag on there that makes it tamper-proof, so you can't go in and reset the dial and try to cheat. There are some other methods of measuring water flow in a pipe. One way is they can shoot a radio wave through the water. They put a receiver on one side and a sender on the other, and they shoot this beam, this radio beam through the water, and it measures how much it deflects due to the velocity of the water. Extremely accurate way to measure. And it's all done external. You don't have to drill into the pipe. You can just go clamp that on any pipe anywhere and make it work. It's a pretty expensive little tool, but it's really slick and really portable, and you can take it around and do thousands of readings a month with it all over the place. It's just going to give you instantaneous readings at that point. So a person could tell how much he was using in a particular system at a particular time. So water measurement is becoming a very major issue. Also, you note in cities, everybody has a water meter. It basically works off this principle of a spinning dial inside a propeller that is spinning, and as it spins, it's recording total gallons used. Oftentimes they'll read cubic feet instead of gallons. A cubic foot is how many? 7.46 gallons. So it's just another way of measuring it. Some municipalities work off cubic feet, some work off gallons.